Hi, my name is Latrinda Knighton, and I would like to welcome you to Got Problems, where we will look at strategies for implementing problems that promote reasoning and problem solving. So let's get started by looking at 6 tasks that I have on the screen. And I want you to take a look at these. I'll put a little bit of time on my timer. And I want you to look at the 6 problems that could be posed to students here. And I want you to see what do they have in common. What are some characteristics that you find similar in each of these tasks? So in looking at these tasks, you notice questions such as can you prove it? Why or why not? So you probably concluded that each of these tasks require students to develop arguments to justify their thinking. Students are not only providing an answer, but they are explaining their work and using mathematics to do that. So that gives you an idea of the types of strategies that we will be exploring in today's presentation. Specifically, strategies that promote problem solving for students. We'll engage in some problem posing tasks. We'll look at the characteristics of high quality tasks that promote reasoning and problem solving. And we'll take a look at some strategies for 3 of the mathematical practice standards that, based on historical data, that our students tend to have some difficulty with success in those practice standards, especially in testing situations. And we'll connect those practice standards to our LEAP 2025 assessments. So let's start by thinking about what are those key principles or thoughts about problem solving? But first of all, we really need to remind ourselves that problem solving in itself is a complex activity. It involves the recall of facts, the use of a variety of skills and procedures, the ability to evaluate one's own thinking and progress while solving problems, and many other capabilities. So it is a multifaceted process that students are engaged in. In order to be successful in problem solving, there are a couple of things that are dependent on that. One is making sure that students are interested in the task, that they are motivated, depends on students' motivation, and their self-confidence. And that's what we want to do by providing our students with rich opportunities to engage in problem solving. We want to build that self-confidence. So one of the first things we have to do in order to make sure that our students are confident and make sure that we are helping them to feel comfortable with a tool and engaging in activities that require problem solving is we have to make sure that we are paying attention to these 8 practices. Now, we know that in mathematics, we have the content standards. This determines what students should know and be able to do at each grade level. But just as important are those standards for mathematical practice. These are the habits of mind. These are the behaviors that students engage in as they learn mathematics. And so each of these practice standards is important for students K-12, but you'll also notice that I've highlighted a word or two from each of these practice standards to remind ourselves that being able to reason, to problem solve, to explain your thinking is built into those behaviors that we should see students engage in on a regular basis. So when we think about problem solving, as I mentioned earlier, it is a multifaceted task. It is a process that requires skills in understanding the problem and the question, finding the needed data, planning what to do, finding the answer, and most importantly, checking to see if the answer makes sense. So it can be a complex process, but it's definitely one that our students are more than capable of achieving. because we want students who are thinkers, not students who are skilled at using a formulaic approach to sometimes get the correct answer, and most cases not get there. We want them to be able to use their thinking skills so that no matter what the situation, they can apply it and they can actually experience success. So when we think about these things, of course, our minds take us to our students being successful in a measure we use, a criterion measure that we use in our state is our LEAP 2025 assessment to examine students' performance in their grade levels at testing grades. So when we think about those task types, there are 3 different task types: type 1, type 2, and type 3. We know that also when we look at those types, those 3 different task types, that there are 4 reporting categories: major content, additional supporting content, expressing mathematical reasoning, and modeling and application. But we have to look at this far right column over here. The mathematical practice standards are also embedded into those assessments. So if our students are not actively engaged in mathematics, they probably won't be very successful in those tasks. Now, one of the things we have to remind ourselves when we look at type 1 tasks, if you've thought in the past that a type 1 task is just a straight recall multiple choice question, you definitely will have to rethink those thoughts, because first of all, it is aligned to all components of rigor: conceptual understanding, procedural skill and fluency, and application. It's based on your major content. So if this is the majority of what students are engaging in class, you know there are going to be some conceptual understanding questions as well as application questions, which can be aligned to any of those 8 standards for mathematical practice. So our students need to be able to think deeply. They need to be able to problem solve and be able to use reasoning in all of the work that they engage in mathematics class. So when we think about reasoning and problem solving, a lot of times we think about what have our results been in these reporting categories. When we think about our district, we think about the state in general. And so I've highlighted 2 of those reporting categories: the 2 that are aligned to type 2 and type 3 tasks, because historically, these are the 2 where our students in our district and in our state typically show the most difficulty with. So that's expressing mathematical reasoning and modeling and application. Those are aligned to mathematical practice standards 3, 4, and 6, respectively. So we definitely want to give some attention there. But keep in mind, if students are better able to solve those types of problems and be more proficient in those mathematical practice standards, that's going to help them with their major content and additional supporting content, because those tasks can involve any of those mathematical practice standards. So when we hear the word task, a lot of times we are wondering, well, why are they using that term when it's really just a question? So when you think about a task, think about just as an adult. You think, there's some work involved in this. This probably has multiple steps. It has multiple purposes. So there's a level of importance that's given there, because that's exactly what students are doing in mathematics. They're not answering a straight recall question. They're doing some heavy thinking and some heavy thought. So the role of task in learning mathematics is very important. We know that effective mathematics teaching uses task as one way to motivate student learning and to help students build new mathematical knowledge through problem solving. Specifically, when we think about implementing tasks that promote reasoning and problem solving, we know that to ensure that students have the opportunity to engage in high-level thinking, which we want for all students, As teachers, we must regularly select and implement tasks that promote reasoning and problem solving. So these tasks would encourage reasoning and access to the mathematics through multiple entry points. So there's that differentiation for all students. Include the use of different representations and tools. Again, that's promoting more access. And they foster the solving of problems through varied strategies. Once again, more access for all students because there's not a the way to do it. So if you take a look at this graphic here, I have on the right some tasks. And so you have column A and you have column B. So what I'd like you to do is take a little time and I want you to review the task in column A and look at the task in column B. Specifically, take a look at the content and what students have to do to be successful in each of those tasks. And make note of how the tasks are similar and how are they different. So I've placed a little time on the timer for you to examine those and take a look. Okay, so there's my timer. So one of the things you probably notice is that when you look at some of the tasks in column A, there are some things that are probably just straight recall. There's at least one naked number problem over there. For example, the second problem in column A says there are 9 bags of apples with 6 apples in each bag. How many apples are there altogether? So kind of typical type problem, probably a type of problem I probably saw when I was a kid in school. If we look at column B, it says write a word problem that could be solved by 9 multiplied by 6. So now there's a little bit more, students actually can have some autonomy. And then I actually have to understand what that means in order to write my own problem that shows that. And so as you take a look at column A and column B, you see that we have questions that infuse some reasoning. There's a little bit more problem solving. Students may have to do more than one step, and they may have to do one part or one piece to demonstrate understanding of a concept in order to get the next part or the next question. And so this gives us a little bit idea of what can we do to provide opportunities for our students to have those rich tasks that are going to be more applicable to those that will promote reasoning and problem solving in the classroom. So one of the things we think about, well, what would be characteristics of those high quality tasks? And so these are a couple of characteristics that we would look for of what makes a high quality task. Some of the things that you see here is encouraging the use of multiple representation. So why? Because there's not just one way to represent a problem. So we want to encourage students to find multiple ways to do that so that what works best for me to show that is going to be the representation that I may use, but my friend Billy over here may choose a different representation. And so I need to be flexible enough as a learner to see, oh, his is correct. He just used a different way to represent that. It's only going to enrich the learning experience for me as a student, connecting previous knowledge to new learning. So we're making connections. Students are using what they know to build on to something more. Engage the students in explaining the meaning of the results. So if I can explain it, there's probably a much greater chance that I truly understand it. Involving students in an inquiry-oriented or exploratory approach. So that's more developmental for all of our students. providing opportunities for students to develop and demonstrate the mathematical practices, definitely being aligned with relevant mathematics content standards, meaning the math that I am working on in my grade level at the moment at the time. Multiple solution approaches and strategies, having a relevant and interesting context. So these are those things that are making students actually have an opportunity to demonstrate their thinking, to demonstrate what they know, and actually to be actively involved in the learning of mathematics. So, a lot of times we find sources for tasks. So, these are 6 questions that you can use when you're assessing the quality of a problem solving task. So, if you find an existing task, these are things you can ask yourself to see, is it high quality? First, is it interesting to students? Does it involve meaningful mathematics? That means when you look at your grade level content standards, is it aligned to the math that your students are doing in that grade level? Something that is meaningful, that it is connected. Does the problem provide an opportunity for students to apply and to extend mathematics? Is the problem challenging for students? It's okay to have challenge. Productive struggle is a good thing for our students because students want to be challenged. They don't want to have something that's easy all the time. Does it support the use of multiple strategies? You want to be able to make sure that all students feel as if there's something there for them. And will students' interactions with the problem reveal information about your students' mathematical understanding? Will you learn something about what they know that you can use as a tool to plan for instruction in your classroom? So, of course, what's the magic thing that we can use to help kids with this? It's got to be those word problems, right? They've been around forever. That's going to be the magic key to help my kids to solve problems, right? And of course, when we think about those wonderful word problems, sometimes we think about things such as this, those key words. Well, are they really key? So as you can see from the examples that I have here, and I've highlighted a key word or key term in 2 of these problems. But if you take a look at both of those problems, if a student does what they typically do, look at the numbers in the problem and take a look at that keyword they've been taught to circle or underline or box or whatever, it's not going to help them be successful in this circumstance. So if we take a look, actually to be completely honest, at recent research, we find that as students progress to 3rd grade and above, 75 to 80% of the times when they're presented with these type of situations in a rich problem solving experience, using a keyword or key term is going to send them down the wrong rabbit hole. So it's okay if you may have been guilty of using things of this nature before, because the reason many of us may have used a keyword or steps approach to teaching problem solving is that we have not had any alternative instructional strategies. And so we want to teach for meaning and understanding, not to have this special trick or this special procedure, because it needs to be something that's rooted in the mathematics that will work all the time, not just some of the time, because we trust and know that our students are better than that. They're smarter than that. They can handle much more. So what are some tools to help our students with that? So I want to share just 4 tools that will help our students, and then we'll look for some things that we can use as teachers, routines we can bring into the classroom. So one of the first things I want to share with you, let's let this load, are numberless word problems. And I know some of you have heard me share these before. And so one of the resources, and so this is also one of the items that's hyperlinked on the informational form that you guys will use to access this webinar. So you'll have all these resources available to you as well, is For each of these problems, we start out by just giving kids a problem that has no numbers. So this forces students to look at just the language of the problem and to talk about the context and what's happening. So here I know that Heather has some stickers. She's going to put into some treat bags for a birthday party, and she puts the same number of stickers in each bag. So kids can talk about, well, what do you see happening? What's the action happening in this problem? They may even think, well, what do you think I may be asked to do to solve this problem? And don't worry, in the slide decks that go with these, possible questions are all listed there as well in the notes section. So then I introduce one number. So now I know that she has 4 treat bags. So she's going to put these stickers into 4 treat bags for the party. So I know a little bit more. What are some questions you may have? What's something you notice? What's something you wonder about this problem now? Very slowly, I introduce another number. Now I know she has 12 stickers. And she's going to put those 12 stickers into 4 treat bags for a birthday party. But then she puts the same number of stickers in each bag. So that gives me a lot more information, tells me a little bit about the mathematics that's taking place. And then last but not least, I get the question. Notice how we have very strategically, but very slowly allowed students to process the information, process the context. So those kids who are a little shy of word problems, it gives them an opportunity to explore those problems in context a little bit more at their level, at their area, and to process that information and to think about it as they go through. So that's one strategy that works very well with students to help them feel comfortable and help them feel success in that area. Another strategy that we use a lot in the classroom, we can use this for problem solving as well. A notice and wonder strategy, where we present students with a problem solving situation. And so just ask, what do you notice? What do you wonder? And so for this one, just so that our students could all interact at the same time, because we want it to be a very quick routine for students to engage in, I just put it on a Jamboard so you could present this to your students, and so students could all simultaneously choose a sticky note and actually share their noticings and share their wonderings. And so students begin to see some of the other things that their classmates have to think about. So before we even have to solve the problem, just want to know, what do you notice? What do you wonder? So that we just think about it. You know, a lot of times we expect students to solve problems of this nature too quickly. Remember, we looked at all those things that are encompassed in problem solving. It's multifaceted. So if we give students the opportunity to take their time and to dissect the component pieces, it gives them a little bit more time to process the information so that they can actually be successful in those tasks. Another tool to help students to unpack problem solving tasks is to give them an organizer that they can use to unpack and dissect their thinking. So here's a problem that could be posed to students. And so they would use a KWS strategy for solving this problem. And so what happens is they have a chart with 3 columns. So I want to know what I know about the problem. What do I want to find out? And then they get to solve the problem. And so this problem with the cans of tennis balls and the store, here you can see a student response to that problem using the KWS chart. What do I want to know about the problem? What I want to find out? And how can I solve it? And then you see their work. So just giving them a process for dissecting that information and understanding the different component parts before they move on to solving their answer. We do this intuitively in our heads, And we do it very quickly because we've done it for a long time, and also because we have formal operational thought. Our students are still growing and maturing to get there. Another tool that is very helpful is this is a problem solving rubric. It's not here because you want to assign a grade or a score, but what happens is twofold. It can be used for the teacher, but also for students. And this is one of my favorite problem solving rubrics. I know in my own classroom, as a classroom teacher, I had little mini copies of this in my students' journals. And so, as we completed application problems or problem solving tasks, my students would look at their responses and they actually would self assess themselves. Notice it is for students, it's written in kid language. What I like about it is it looks at three big components: showing your math knowledge, using problem solving strategies, and writing an explanation. So at all times, they're thinking about have they done all three. And so students can see with the 5, 4, 3, 2, 1, where did they fall or where were they on this rubric. And then they can make some goals for themselves. If most of the time are very good at doing the problem correctly, but did I show all of my steps or my drawings? If that was something that was very important with showing my work, because sometimes you're asked to do that, are some things I need to improve in that area. Notice what happens when it says writing an explanation. What if I'm always forgetting to write anything about how I solve the problem? So I probably live in that world of ones or twos, but I can set a goal for myself to do a little bit better so that I'm telling more about what I did. So I like having a tool that students can use to self-assess and help to monitor their thinking and their work. So those are a couple tools that we can use for students. So as we go back and we look at those practice standards, and we actually look at each of those 8 standards, and we think about where those practice standards could be assessed, or where students may have to use those in when they think about type 1, type 2, and type 3 types of problems. And we think about some of the strategies we just looked at, some of the tasks, some of the ideas. We can see, where do these things lie? But as I promised, we are going to look a little bit more closely at 3, 4, and 6. So we can look at those areas where we find that our students have not always performed very well historically on statewide assessments. But also keeping in mind that if we help students to be stronger students in those areas, it will ultimately affect their performance in the others as well. So let's take a look. Let's see how we can put the pieces together. We've looked at those components of problem solving. We've looked at some strategies to help students. Now let's look at some things that we can do as teachers in the classroom. So when we think about mathematical practice 3, which is one of my favorite, constructing viable arguments and critiquing the reasoning of others. In a nutshell, this means that students can justify their answers and processes. They can effectively communicate their justifications, and that can be talking, writing, drawing. There are many forms of communication, remember? And they listen and react to the ideas of others. Students have to be involved in having discussions with each other because really they learn so much from their peers. And to be completely honest, I learned a lot from the kids as well. So what does that mean? What we will see students doing as they engage in this practice standard? Justifying solutions and approaches, listening to the reasoning of others, comparing arguments, and deciding if the arguments of others make sense. So that goes back to those traditional questions they'll see with reasoning in a type 2 situation. Here's a very simple routine. Eliminate it. Now, this is one that actually uses some measurement terms. And so students look at those 4 terms. They have to choose one to eliminate, and they have to tell why. And they need to use mathematics and reasoning to tell why that one does not belong. Here's one using numbers. Some kids may choose the one in the lower right hand corner, 84, because it's the only even number. And might justify it with that. But then there are other reasons that students may use some of the others as well. As long as they can use mathematics to justify their answer, they're correct. So what can we do as teachers to help students to be successful with mathematical practice 3? Asking good questions. That means why, how, what if. Not open-ended questions that can be answered with a yes or no. Ask students to defend their actions and answers both verbally and in writing. Provide opportunities for students to listen to or read the conclusions and arguments of others. Establish and facilitate a safe environment for discussion. And avoid giving too much assistance, providing answers or procedures for students. Students are very, very smart. And when given the opportunities, they will surprise us every time with the things that they're able to do. So other things that students can do to be successful is to give them opportunities to investigate examples with representations, construct arguments based on representations, and maybe have activities where they are constructing viable arguments, critiquing the reasoning of others with contrasting operations. That goes back to 7 and 8, looking at those structures and having them use what they know about those operations and to explore those strategies as well and those concepts. Encouraging students to articulate what is happening. Can you put into words what you think is true for these examples? Make an argument about why your idea is true using a representation. All of these things are encouraging sense making in our students. So let's look at mathematical practice number 4, model with mathematics. In a nutshell, it means that students can represent math ideas using pictures, diagrams, tables, and charts. They can analyze math situations through models and draw conclusions. So, for example, having students use just grids, 10 by 10 square grids, to visualize those concepts. And so what value do each of these model? So they think about this and what does it mean? This is something very simple that kids can use and a very simple problem to pose. So they're actually looking at a model, but then later they can create models of their own. What do we see kids doing? Representing numbers, equations, formulas in varied ways, using representations to solve problems. Remember, that goes back to one of our other practice standards that students are able to use representations. So notice how these are all intertwined and they affect each other. So what can we do as teachers? We can make models available. We can use models in our instruction, vary the models we use, and be sure that we understand the models that we use so that we're using the model that is best suited for that situation. Attend to precision, mathematical practice number 6. So in a nutshell, that means that students can calculate accurately and efficiently. Now, does that mean that they need to memorize a bunch of mad-minute facts? No, it does not. Because being able to do something accurately and efficiently doesn't always mean memorization. In most cases, it doesn't. Students will use strategies to solve a problem or use a smaller problem to solve a bigger problem. Students can precisely communicate their mathematical thinking using clear definitions and state the meaning of symbols. And a clear definition doesn't mean the Webster's definition. It means a definition that makes sense all the time, and it should be student friendly. So this is a great one, using the broken calculator. I want to make 78 using my calculator, but the 7 key and the 8 key are broken. How could I make my calculator display show 78? This is so much more than I'm just finding something to show that. This is me as a student thinking about what operations can I perform, what smaller facts possibly can I use to get there so that I can find that total. And so this goes back to thinking about efficiently, but also thinking about having those varied strategies that students can use to solve these types of problems. What types of behaviors will we see in students? Students being able to calculate accurately and efficiently, students explaining their thinking using mathematics vocabulary, using appropriate symbols and specified units of measure. What can we do as teachers? We can recognize and model efficient strategies for computation, use and challenge students to use mathematics vocabulary precisely and consistently, and explore math vocabulary. Remember, our students are a lot more sophisticated than sometimes we give them credit for being. When students are looking, for example, at inequality symbols, we can use greater than, less than, and use the context of a number line to explain those concepts to students. We don't have to talk about an alligator opening or closing its mouth. We actually can use mathematics to make sense of those things for our students. So, what's our role as teachers in promoting problem solving? Definitely, we want to allow students to solve problems with real life applications. We want to encourage collaboration and promote dialogue among students, allow time for students to talk about mathematics, provide opportunities for problem solving, and incorporate problem posing into classroom activities, and use tasks that rouse student interest and allow students to make real life applications. Everything we do is about promoting that sense making. So I want to thank you for joining me for this presentation. Remember that on the associated quiz, the Google form, you will have a link to our attendance and feedback form. So I encourage you to complete this so we can, one, document your attendance. You can provide me with feedback or additional questions or even a request for support that you may have for this topic or other topics. Also, the links to the things that I referred to in this presentation will also be included there as well. So you'll have the link to the numberless word problems, the link to the problem solving rubric, and some of the other things that we've discussed in this presentation as well. So I definitely want to thank you for engaging with this presentation. I want to encourage you to use some of these strategies to promote reasoning and problem solving with your students. And just feel free to reach out to me. You have my email address here. You'll also have it on that Google form if you want me to come in and plan a problem solving lesson with you, to model a lesson or a routine as well. So thank you so much and enjoy your day.